Have you ever noticed how the surface of water moves differently depending on the size of the ripples? From tiny shivers to powerful ocean swells, water has fascinating ways of responding to forces. Capillary waves transition to gravity waves primarily due to a change in the dominant restoring force acting on the water's surface. For very short waves, surface tension is the main force trying to flatten the disturbance, but as waves grow larger, gravity takes over this role, becoming the primary influence. The underlying mechanism for this transition lies in the physics of restoring forces. For small, short wavelength disturbances, typically less than 1.7 centimeters, the cohesive forces between water molecules, known as surface tension, are powerful enough to pull the water surface back into a flat state. These are capillary waves. However, as the wavelength increases beyond this critical point, the mass of the displaced water becomes significant enough that the force of gravity, pulling the water downwards, exerts a much greater influence in restoring the surface to equilibrium. At this threshold, gravity waves begin to dominate. Understanding this shift helps us categorize and predict wave behavior more accurately. For instance, those tiny ripples you see when a gentle breeze skims across a pond are capillary waves, while the larger, more imposing waves that break on a beach are classic gravity waves. Knowing this distinction allows oceanographers and engineers to apply the correct mathematical models and physical principles to study different wave types. This shift at about 1.7 centimeters is not just a theoretical concept. It is a fundamental aspect of fluid dynamics and plays a crucial role in how energy is transferred from wind to the ocean. The unique dispersion relations governing these two wave types also explain why capillary waves travel slower as their wavelength increases, while gravity waves travel faster with increasing wavelength, a key characteristic that distinguishes them. Ultimately, the transition from capillary to gravity waves is a beautiful illustration of how fundamental physical forces dictate the dynamics of our natural world, allowing us to understand and even forecast the intricate dance of water on oceans, lakes, and rivers.